You know, fire. We've been staring into it for, well, forever, right? It dances, it glows, it flickers. But have you ever just stopped and wondered, what is it actually? It seems so simple, but it's hiding some absolutely incredible secrets.
So to really get a grip on what it is, let's start with what it isn't. It's a classic process of elimination.
I mean, first up, it's definitely not a solid. Pretty obvious, right? You can't just pick it up or hold it in your hand.
Okay, and it's not a liquid either. You can't pour it into a cup like you would with water.
So, not a solid, not a liquid, gotta be a gas then, right? Well, hang on. It's not that simple. A flame is something else entirely, something way, way stranger.
And here's the big reveal. The most crucial thing to understand is that fire isn't a thing at all. It's a process. When you watch a fire, you're watching matter transform right before your very eyes.
Scientifically speaking, fire is this super fast chemical transformation we call combustion. It's basically a reaction that's unleashing stored up energy, and we get to see and feel that energy as heat and light.
So, what's that glowing shape we're actually looking at? Well, that's not the fire itself. Nope. It's just the plume of super hot, energized gas that's created by the reaction. It only looks alive because physics is forcing it to move. All right, so if it's a process, how do you get it started? Well, like any good recipe, this transformation needs a few key ingredients. 3 to be exact.
And here they are, the famous fire triangle. First, you've got to have fuel. Something to burn, like wood or natural gas. Second, you need an oxidizer, which is almost always the oxygen in the air around us. And third, you need heat to get the whole party started.
And this really shows you just how essential each one of those pieces is. Take away just one of them, and the whole thing just collapses. When you pour water on a campfire, you're yanking away the heat. A fire extinguisher, that's designed to shove the oxygen out of the way. And when a log finally burns down to ash, well, it's simply run out of fuel.
Okay, so we've got the process, we've got the ingredients, but what about the best part, the glow? Where does that light actually come from? This is where we have to zoom way, way in, down to the atomic level. The energy from that chemical reaction gets the electrons in the gas atoms all excited, bumping them up to a higher energy level. But they can't stay there. When they fall back down, they have to release that extra energy, and they do it by spitting out a tiny particle of light, a photon. Billions and billions of these photons are what make up the flame we see.
And get this, the color of that light tells you a whole story. A really hot, efficient flame, like the one on your gas stove, burns a brilliant glue. But a cooler flame, like from a candle, has that classic yellow-orange glow. Why? Well, that color actually comes from tiny solid bits of carbon, soot basically, that get so hot they start to glow. The color is like a fingerprint of the flame's temperature and its chemistry.
Okay, let's talk about the shape. Why does a flame almost always have that iconic teardrop look, always reaching for the sky?
The answer is kind of wild. It's gravity. See, the gases inside the flame are incredibly hot, way hotter than the air around them. That makes them less dense. And just like a hot air balloon, less dense stuff rises. So that constant upward rush of hot gas is what pulls the flame into that familiar flickering teardrop.
Which, of course, leads to a really cool question. If gravity is what gives fire its shape here on Earth, what would a flame look like if you just took gravity away?
Well, in space, with no gravity to boss it around, fire shows us what it's really like. With no up for the hot gas to escape to, the combustion just spreads out perfectly, evenly, in all directions, forming a perfect, glowing sphere.
Yeah, no flicker, no dance. It's just this steady, slow-moving bubble of combustion. It's a completely different, almost peaceful vision of fire, something you can only see when you change the fundamental rules of the game. So let's zoom out for a second. This everyday process we see in a campfire actually has a deep, profound connection to the rest of the universe. That little flame, it's matter, right on the edge of becoming something else. And that something else is called plasma. It's considered the fourth state of matter. It's what you get when a gas gets so ridiculously hot that electrons are literally torn away from their atoms. This creates a sort of superheated, electrically charged gas. And don't think plasma is some rare, exotic thing. It's actually the most common state of matter in the entire universe. I'm talking over 99% of everything we can see. Our sun, a giant ball of plasma. That bolt of lightning, a searing hot channel of plasma.
Even the gorgeous auroras are just plasma, dancing in our upper atmosphere.
Now, to be clear, a simple candle flame isn't entirely plasma, but parts of it can get hot enough that some of the gas does start to ionize. It starts to turn into plasma. That tiny little flame on your birthday cake is touching the very same state of matter that powers the stars. How cool is that?
So, let's circle back. What is fire? It's not a thing. It's a transformation. It's this beautiful dance of atoms breaking apart and coming back together. It's the glowing, visible footprint of matter itself changing shape.
And that's really the thought I want to leave you with. If something we see all the time, something as common as fire, holds this much incredible complexity and beauty, just imagine what other amazing transformations are hiding all around us, in plain sight, just waiting for us to stop and really look.